in the previous part. In the previous part, we studied free fall. Free fall, by definition, is the motion in one dimension under the effect of gravity alone, no air resistance. That was in one dimension. We call free fall. Projectile motion is a motion instead of one dimension in two dimensions under the effect of gravity alone. So instead of being in one, it's in two dimensions. And that is called projectile motion, or motion of the projectile. So we will study here three basic, three motions, three types. One, when you throw horizontally. So imagine that you are in a cliff and you dive horizontally like this to the water. So this is the first type of projectile motion. So can you see that after leaving my hand, this object will be under the effect of gravity alone. Doesn't depend on anything else. Look, it goes out, that's it. It's under the effect, it depends on the force that I give, but after that, once get the initial velocity, the subsequent motion will depend on gravity only. This is not free fall. I am using my hand. It's not under free fall. But this is free fall. Two different things. The second type of motion is when you throw from the ground to the ground. Imagine that you are kicking for a football, for a field goal. From the ground, and the ball will go to the ground like this, which the path you can see that is symmetric. And this is a long, flat range, like this. And finally, the third type of motion is when you throw like this, from the cliff at an angle like this, which is when you throw a basketball. You don't throw the basketball from the ground. You throw from a certain height and goes to the ground or to the basket. But sometimes you can throw and go to the ground, or when you kick, instead of for a field goal, when you are punting from a certain height. This is the third type. So we will describe these three types of motion. In order to describe the three types of motion, we need to get what is the acceleration, what is the velocity, what is the position. And that is what is kinematics. All right. So starting to understand that motion, the first thing you need to understand here is that always the first thing we will find is when you throw the velocity vector at any point, the direction of the velocity vector, if I ask in which direction will be the velocity at this point, you need to trace a velocity vector always will be a tangent to the path. At this point will be here. At this point will be here. At this point will be here. And so on. Any question on that? So if you want to see the direction of the velocity at a moment, you just find a tangent to the path at that moment. And that will be the velocity vector. The direction. The magnitude, we don't know. I have to give numbers. For example, here will be like this. But here, my velocity vector will be like this. Because the effect of gravity, it will go and come at this point, flat, like this, horizontal. And then here. The same will be here, here, and so on. This is the moment of impact. This is at the maximum height, and this is at the initial moment. Knowing that, the first thing we will calculate here, again, Galileo said that the best way to solve all this problem is treating the coordinate independently. So, Galileo said, because the object, once leaves the hand, is under the effect of gravity, means that if I throw, for example, if a plane throw a packet, humanitarian help, and it's going at constant velocity along x, when this plane is here, this packet will be on the same line of sight if it's moving at constant velocity, right? If he throw a second packet here, when this go to here, or this is here, this packet is here. At this time he throw another one, it will be here. Now, if at this point he throw a third one, when this is here, this will be here, and this will be here. Because the along x, you are moving with the plane. It's like when you go, imagine that you go in the plane, or you go like this, and you are on the truck, and you jump. Not suggested to do it. But if you jump and the driver is moving at constant velocity, and you are on the trunk, where you will land? In the trunk. And you can do that in a plane. You go to a plane, be careful, because sometimes they can think that you're crazy in the plane or whatever. But if you jump in the plane, you will see that you will land in the same place. You won't land in the bathroom. You will land in the same place. So the same will be if I am walking at constant velocity and I throw this. You can see if I am walking at constant velocity and I throw this. This will land in my hand. Because along x, there is nothing acting on the object. You understand what I mean? But along y is something acting, which is the gravity. So if I throw at the same time two things here, like this, one I throw this way, and one I drop at the same time that I throw this, so they will hit at the same time. Because this is the only force acting on this, and you can see that if this, I throw this, I throw one, and I drop the other. So if I throw at the same time, they will land at the same time. Which means that along x, the acceleration is 0. Nothing is acting. There is no acceleration along x. And along y, what is the acceleration? Negative 9.8, which is negative g, or negative 9.8. If we go to this equation, because the acceleration along x is 0, it's a motion at constant acceleration, but it's a 0 acceleration, which means that the velocity, if I go to this equation along x, this will be vxo. This is the acceleration, which is 0 along x. So what tells me that the acceleration is 0 along x? What will be the velocity of this and this all the time? The same. So Vx is equal always to Vxo. Any question on that? And along, then if we go to the third equation, this delta x, here the acceleration is 0, all this vanish, and when I find the square root, Vx will be equal to Vxo, same equation. So all this will be reduced to that equation, and delta x, because xo is 0, xo is 0, and xo is 0, x is equal, and this is 0, x will be equal to what? And this is the equation for motion at constant velocity. This, distance, velocity, time, for motion at constant velocity or uniform motion. So along x is uniform motion, along y is uniformly accelerated motion. So these are the three equations for the x motion, important. And for the y motion, the same big three. Vy is equal Vyo plus the acceleration along y, which is how much? Negative 9.8. the second equation will be y, yo, plus byo, plus 1/2 ay t squared. But remember, ay will be replaced by negative g, or negative 9.8. And finally, by squared is equal to byo squared plus 2ay y minus yo. This will be the question for projectile motion. One more thing important. Always, you will start the problem, always. If you don't have value, even symbolically, always you will start the problem finding bxo and byo. So if I give bo and theta o in the problem, how can you find bxo? If I give bo, the magnitude, and theta o, how do you find this component and this component?
Using sine
and cosine, which we learn in vector analysis. So the x component, how do you find it? Bo cosine theta o. And how do you find byo? Good. This will be the first point. The first thing you do, even if they don't ask, in projectile motion. The rest you think about what is given and then you start finding. Another thing, always in the three problems, look at the velocity vector at the maximum height. What can you note about the velocity vector at the maximum height in the three problems, in the three cases? What can you know? What do you see? At the maximum height, what do you see in the velocity vector? How it's pointing?
There's no y component.
There is no y component. It's pointing horizontally. What is the meaning that it's pointing horizontally at the maximum height? What will be by? Like in free fall? No acceleration. No, there is acceleration, but not on the x direction. So what is the meaning of that? That there is no component of the velocity vector y component. What is by? 0. So by is 0 at the maximum height, at only the y component. The x component is not 0. So I haven't seen that when you throw an object, get frozen at the maximum height.